Right, everyone, let's get going with lecture 23. And we're going to continue our theme of melting glaciers and how these are going to impact human populations, especially in mountainous areas. So we talked on Wednesday about the fact that that increasing melt of our glaciers means that we're getting more meltwater which can pile up either on top of the ice or in front of the ice and can release these catastrophic floods. And those are a real threat to mountain populations, but perhaps what's more of a threat to more people, to millions of people in fact, is the fact that glaciers in a lot of our mountain regions are contributing drinking water and irrigation water to downstream populations. And what we want to look at today is how the disappearance of glaciers might affect the amount of water flowing in our streams in different parts of the world. So as a reminder, quiz 9, nearly there guys, is available from 3:30 today until 2 on Monday. Also, do you vaguely remember this from the first week, which seems a very long time ago now, that this class is part of a research study. We're trying to understand a little bit more about the students in our GE classes and what you learn. And so if you would like to make up one of your days of iClicker answers, then please take the opportunity to fill out the second survey, which will be open from 5 p.m. today until the Sunday before finals week. And you can see the instructions of how to find it at the base there. And remember that you can take the survey and not participate in the overall study if you would like to. I won't see your answers. All I'll see is a name or a list of names so that I can award you points if you want. But I hope that you do choose to do that because it will hopefully benefit, if not you, then definitely future classes when we understand a little bit more about what you learn. Okay? Does anyone have questions for me about this? Nope? Okay. In that case, on to the science. So I showed you this slide on Wednesday when I said that when we have melting glaciers, we have certain implications, and definitely we have floods from these big outburst events. But we also just have flooding because we have more water running through our streams coming off these glaciers. And also the second thing that we're most concerned about is the fact that eventually, as our glaciers disappear, we're going to get a real decrease in the amount of water in a lot of areas. And that's a concern for various countries around the world. So, to insult your intelligence, I wanted to show you the hydrologic cycle. So everyone has done this at school. I don't want to dwell on it. But the idea is that remember that the Earth is a closed system. There's only so much water on Earth. And so it circulates around as part of this hydrologic cycle through the atmosphere, ocean, in the cryosphere, and then through sort of the biosphere and across Earth's surface back to the ocean again. Okay? So we have this water circulating. And remember that when we're talking about water supplies, the whole problem is that we have a lot of water on Earth, but most of it, the vast majority of it, is salt water. 97% of it is salt water. And of that 3% that is fresh water, a huge amount of it is either locked away in glaciers and ice caps, in pretty inaccessible places where we don't have a lot of population, places like Greenland and Antarctica, where it's really not much use to us. And so the little remaining mountain glaciers are pretty helpful as a water supply. Then we have our groundwater, which we know we make a good use of here in California, and then other little supplies for lakes and streams. So my first question of the day is, what would happen, or what did happen, to the ratio of fresh water to salt water during the last ice age? What would happen to that ratio, that fraction of fresh water to salt water during the last ice age? So think about it for a minute. And then give me your answer. And you can consult your neighbors if you would like. Are there any more votes? Right, let's take a look and see how awake people are today. Awake-ish. Okay. So you would be right that the ratio would increase Why? Tell me why you put that. Why did you put yes, at the back there?
I think I'm going with freshwater, more likely to freeze.
Yes, absolutely. So we do have more freshwater because we have more ice. We have more ice on land. And so if you imagine what's going on, we're having this evaporation from the ocean, and that's being dumped on land, and it's staying there. It's not flowing back into the oceans. And so we have a lot more fresh water forming our big ice sheets. Do you remember we looked at that map, which shows those really big ice sheets across North America and Europe? And so we had a lot more fresh water in the past. And in the future, we're potentially going to have less as a result of the same factors. Okay. So how important is our glacial water supply? Well, nearly 2 billion people, 2 billion people out of the 7 billion or so on Earth right now get their water, at least in part, from mountain glaciers and also snow cover. And it's really particularly important for countries around the Himalayas and in the Andes, which, remember, in South America. We're going to talk a lot about countries there today. And so we're concerned that we could get water shortages in some of these places. Particular countries at risk are Bolivia, Colombia, Peru, which is already a very dry country. Also Pakistan, we'll see a couple of examples later on. Okay? But Peru in particular is already having to think very hard about what might happen to its water supply, because up to 80% of the water there is from snowmelt or ice. So what happens when we get rainfall and precipitation? Remember that when our rain falls on our ground, a certain amount of it will sink in. But for example, when we saw those huge storms just last week, we know that the ground gets saturated really quickly. And after that, that water will run across the surface and it will flow into streams and then down to the ocean. When that precipitation falls as snow, it can build up for a while as ice. And then when that ice melts, again, that water will run, either sort of seep down into the groundwater or run into streams and channels. And so that's sort of where the water ends up moving. And when we talk about water supplies, we often talk about catchment areas or drainage basins. They mean the same thing. So drainage basin is the same as a catchment area. And here you can see the catchment area or the drainage basin for the Mississippi River, which drains a huge, huge amount of the USA, actually, if you look at it. And where are its borders? Why does it only drain, say, this side of the US? What's in the way? Yeah. The mountains, okay. So it's as simple as that. If we put a drop on one side of the mountains, it would run down one way. If we put a drop on the other side, it would run down the other way to the other ocean. Okay? So big topographic features like our mountain ranges tend to form the barriers and form the edges of our drainage basins. And so they can be absolutely, truly enormous, like the Mississippi, or they can be just a little bit smaller if they're just within mountain ranges. So why are glaciers so helpful? Well, they basically act as little reservoirs. So we today build reservoirs to store that water, to stop it flowing into the ocean in our streams and rivers so that we can use it later. Well, the nice thing about glaciers, and to a certain extent snow, if you remember that far back in the quarter now, is that it does it naturally for us. It collects that water and it stores it for us, and then it tends to release it in those warmer months. And especially when those warmer months coincide with our dry season, then that could be hugely helpful. It means that we don't have to build reservoirs. They're already there for us. Okay? And so our glaciers affect the flow in rivers, first of all, daily, because in the middle of the day, we'll get more melt, and so we'll see a daily pattern in the amount of water coming down our streams. But more importantly, seasonally, we'll see a change. And even now, over the next 100 years, we're going to see a much longer scale change as well in terms of an increase and then a subsequent decrease. Okay. But the impact of melting ice will depend on a number of different factors that are very specific to that particular catchment area. So things like whether there's rainfall or snowfall for different parts of the year, whether there's groundwater. If there's groundwater, you're not perhaps as vulnerable. How much rain or snow you're getting, how variable is that? So all of these factors come into play. So before we look at that, we're going to do some drawing. So everyone get out their pencil and paper. So I'm afraid there's thought involved today, and I know that you're not feeling very alert, but you can do this. So first of all, we're going to draw some diagrams to show what would happen throughout the year with different patterns of precipitation and different patterns of snowfall and stream flow. So first of all, my very first example, okay, draw a little graph, and I'm going to go from fall to winter, to spring, to summer. Okay? And on this side, I'm going to have stream flow, so how much water is coming down in my streams. And it's basically going to be on the same scale as precipitation, whether that's snow or rain. Okay? So first of all, my wet season for this particular case is going to be the winter. We're going to see a little bit more rain, and then we're going to have a dry season in the summer. So, for example, my precipitation might look something like this, where we have a peak in winter, and then we have basically very, very little rain or any at all in the summer, and then it goes up again. Can you think of anywhere in the world that might have a precipitation pattern like that? Here. Here is a good bet. Yeah, absolutely, because we know that it hardly ever rains in the summer, right? It's really, really unusual. There might be a thunderstorm, but even here we hardly see that. So really most of our rain comes at this time of year, and the problem this year, of course, is that it hasn't. We've only had that one really big storm. So this is sort of what our particular rainfall pattern would look like. So if everything was just falling as rain, so there's no snow anywhere, there's no ice, what would the pattern be of my streams? When would I see the peak stream flow? Yeah. Winter. Okay. So that rain is falling, and it's going straight into our rivers and streams, and it's going out. Okay. So unsurprisingly, in this case, my rainfall or my stream flow would follow my precipitation. There might be a couple of days of a lag as it sort of has time to sink into the ground and towards the streams. But if I can get this pen to work, it would probably follow more or less exactly the same pattern, just slightly offset. Okay? And so those streams would really dry out in the summer and then flow most in the winter. Does that make sense so far? Everyone can cope with this bit. So it's going to get more complicated. So that's a nice idea in theory, but what we're interested in is what's going to happen if there's ice, if there's snow around. What's going to happen to that pattern that we see? Okay? So for my second example, I'm going to challenge you to basically draw the same thing. So here we have basically an identical graph going fall, winter, spring, summer. On here we have stream flow or precipitation, which I'm going to call PPTN. It's basically just rainfall and snowfall. We're going to have exactly the same pattern in terms of when that precipitation happens and how much of it happens. Okay? But now I want you to think for a couple of minutes, speak to your neighbor. What happens if that precipitation falls as snow in the winter? What would happen to our stream flow? What sort of stream flow would we have in the winter? What sort of stream flow would we have in the spring and summer? Okay? So speak to your neighbor. The TAs around, wave at me, TAs. One there, one there, one there, one there. All nicely spread out today. So speak to them. It's all gone quiet. Is that because you know the answer or because you're watching me desperately hoping that I will give you the answer? One of those two. Okay, so what would happen? What would my stream flow look like in the winter, do you think? Yeah. So would I have low or high stream flow in the winter?
I think low.
Low, yeah. Why?
Because it's cold.
Because it's cold, it's trapped as snow, right? It's building up. And so it's not actually entering our streams, okay? We might have a little bit entering our streams if a little bit of that snow is melting. But really now, instead of having nice high stream flow in winter, we have relatively low stream flow in that fall and winter, probably a little bit more in fall, but low in winter. And then what will happen? What will happen in spring? Yeah.
The snow will start to melt and the stream flow will go up.
How much will it go up?
A lot.
A lot, absolutely. Yeah, we'll get a huge amount of water coming down in spring, right? So all of that rain, or not rainfall, all of the precipitation that fell over winter, all of a sudden when spring comes around, we'll see a big sort of rise in the amount of water coming off. Then what will happen though? Will I continue on quite high all throughout the summer? Because what happens to the amount of snow we have?
It's all melted.
It's all melted, okay? So depending on how quickly that snow melts, but certainly if it melts relatively quickly, which it often does in California, we know that those mountains are pretty snow-free often by the end of the summer, then really by the end of the summer again, we could be down at zero. It sort of drops off relatively quickly, and this is our dangerous time for things like forest fires. And then at the end of the summer, when rainfall picks up again, will increase. Do you have something that looks like that? Yes? Good, good. In that case, let's get a little more complicated. Okay? It's good for you to think. Stop groaning at me. So, let's draw our little graph again. Okay? So again, we're going to go fall, winter, spring, summer. Okay? And so again, we have stream flow or precipitation. So again, I'm going to have exactly the same pattern of precipitation. I'm not being particularly difficult about this. Okay? So a wet season and a dry season. But now I want you to think about what would happen if there are glaciers up in the mountains. Okay? What will happen if we have certainly some snow in the winter, but probably a mix of rain and snow, but now we do have glaciers, okay? We do have glaciers as part of this drainage basin. So again, consult your neighbors, talk to the TAs. What do you think would happen to the stream flow throughout the year now? Okay, so what do you think? What might we have during winter? Do you think we're going to have low or high amounts of stream flow? Low-ish. It sort of depends on the mixture of snow and ice we get, right? Or snow and rain. But definitely in fall we might have some that might sort of decrease a little bit in winter. Depends how much is falling as rain and how much as snow. What might we have in spring? High or low? High? Certainly if we have lots of snow, we're going to get higher, right? Okay. So we're going to get higher again. What will happen through our spring and summer? Is it going to stay the same, go up, go down? So I saw someone there say the same. Who agrees the same? Excellent. A confident person at the back, and he is right, as are you. Okay? So it would stay pretty much the same, because where would our water be coming from now? What's different? Glaciers, absolutely. So we're not talking about snow cover now. The reason we had this peak before and then it dried out again was because we have snow. And there's only so much of that snow. Once it melts, it flows into the rivers and is gone. But if we have big glaciers up in our mountains, then we're not going to be able to melt them every spring, right? So throughout the summer, when those temperatures are high, we're going to be having a steady supply of water coming off them. Does that make sense? Yeah? So we'd actually have a pretty steady, nice water supply through the summer from those glaciers. Okay, so we'd have lowish during winter and then sort of a bit of a peak in spring, but then it would continue relatively high, and then as it cooled down at the end of the summer again, we might go back and we could sort of match our rainfall. Okay, so one last one. Okay, so again, draw yourself a fourth. So we have fall, winter, spring, summer, stream flow, or precipitation. So now I want you to think, we've been talking about northern hemisphere, right, where it's sort of warm in the summer. Well, really any hemisphere is always warm in the summer. So now I want you to think about what might happen if our dry season is actually the winter and our wet season is the spring and summer. Okay? So again, we do have glaciers here. So what would our stream flow be like in this case? So again, I'll give you a couple of minutes to think about it. So if you can draw it. So what would my stream flow be like in winter? Low or high? And how low? Really low, okay? Because we're not getting any rain and we're not getting any melt. And so my stream flow would be really low at this point, okay? It would be down here somewhere. What would happen when spring and summer came around? High. How high? Really high, absolutely, because now we have both the rainfall and also the snowmelt coming down, okay, and the ice as well. So then we would see a sort of a bigger peak in spring and summer, and then that would decline again, okay? So I think it's valuable to draw these things out because sometimes there can be quite a lot of factors involved, and you can see how the timing of that precipitation, the amount of the precipitation, how much of it is falling as rain compared to how much of it is snow, whether you have ice or not, how much ice is in your catchment area, all these things are going to really affect basically how vulnerable you are to to changes. Because remember, when we're talking about water supplies here, we're not talking about if you've always had a wet and a dry season, you're probably pretty adapted to that. Okay? If you've always had a wet and dry season, then that's fine. Your agricultural system is adapted to that. But if you've had a wet and dry season and glaciers have been keeping you going through that dry season, and then that changes, then you're going to be in trouble. Okay? So it's not the case that you just always need water. It's just if it really changes due to the loss of those glaciers, then we're going to have populations that are struggling to cope. So let's see if people have this or not, because I have a very handy iClicker question. Okay, so I have 4 panels here. The 2 on the left are from the Alps. The 2 on the right are from the Andes. Okay, and so the blue shows stream flow. The green shows precipitation. 2 of these are from from a catchment area with lots of glaciers. 2 of these are from a catchment with very, very few glaciers, if any at all. So tell me, is it the top 2 that have glaciers or the bottom 2? So I'm going to give you a couple of minutes to think about this. See if you can work out what's happening in those different areas and why. Okay? So feel free to consult your neighbors, your TAs. I think that's more or less anyone. Are there any more votes for me? Right, let's see how we did. Too close. Consult your neighbor again. There wasn't enough talking there. So speak to the people behind you if you already spoke to your neighbor. So I think that's nearly everyone. So vote if you haven't had a chance to. Right. Let us see if we did any better. We did a lot better, and we even got the right answer, which is also a bonus. Great. What gave you the clue? Which one is the most obvious one in terms of not having glaciers? Bottom right, why? Because they match. Do you remember the very first diagram we drew? We said if everything just falls as rain and goes straight into our rivers, then our stream flow is going to basically match our rainfall. Yep. And that's what we see in the Andes when there are not many glaciers around. Okay? It just sort of falls down. Why do you think that in the Alps we might not be seeing quite the same thing in our bottom left-hand diagram here? What might we have in the Alps that we're not getting in the Andes? snow, absolutely. If you've ever been to the Alps or if you've ever seen postcards or something, it's snowy. So in the Andes, we're in pretty tropical places. It's quite warm. We don't see a huge seasonal range in temperature. In the Alps, we do see a real difference between summer and winter temperatures. And in the Alps, what must be happening here is that we're getting snow. And so again, we see a slightly less stream flow in the winter and a little bit more in the spring. Okay? So our top diagrams show that we have glaciers around. And again, which was the most obvious clue? Which place was the most obvious one? Everyone's stunned into silence. The Andes, again, were some of the most obvious, right? Because you can see that we still have exactly the same precipitation pattern as the bottom diagram here. But you can see that instead of our stream flow following our precipitation, we're getting a little less in the winter because it's probably falling as snow on that ice. And then we get stream flow throughout the summer, even when there's no rainfall. Okay? And that's most likely coming from ice. It's not sort of a little peak in spring. It's consistent over the summer, and that's coming from our ice. You can see in the Alps that really the pattern that we get, is it that much different from the catchment areas with no ice? Is there much difference between the top and the bottom panel? Not really. So which of these locations is going to be more sensitive to the loss of our glaciers? Which location will you find populations that are depending on meltwater from ice that might disappear in the next 100 years?
The Andes.
The Andes, absolutely. Because in the Alps, we're already seeing, or even if we have ice or we don't have ice, we see more or less the same thing. Our farmers are adapted to that. What we see in the Andes, though, is that if we see a disappearance of that ice, we are going to see drastically different patterns of stream flow. So in the Alps, we don't really see that because we have snow. In the Andes, we don't necessarily have that sort of big scale snow melt. And so we see really different patterns between catchment areas with ice and catchment areas without. So if we do lose our glaciers, then people will lose their summer water supply that they have been depending on. Does that make sense? Yes? Bit too much thought for a Friday? Yes? Okay. So when you're studying for this, I wanted to give you a little bit of a hint about what to think about. So think about when the most precipitation is in those places, when people would need that precipitation. So we don't really need it in winter so much. We need it in spring, summer when things are growing. When is the most stream flow? And what effects do glaciers have and what effects does snow have on these different places? Okay. So our impact of glaciers, we can sort of summarize that our impact will be greatest when our ice melt occurs in a dry season. Okay? So if our dry season corresponds to our warm summer months, then our glaciers can contribute lots of water, and so we're going to be vulnerable to the loss of those. Glacial meltwater is also most helpful where it flows into semi-arid environments. Because remember, rivers can go a really long way. So, okay, we get snowmelt in our mountains, but that brings it down to us in LA where we're very, very dry throughout the year, right? And so it really has the biggest impact where that water is already going into very dry places. And small temperature fluctuations, such as those that we see in the Andes, which are nice and tropical, we're not seeing big winter-summer changes. That's where we're going to be most sensitive to loss of glacial ice. So, not giving up on you today. Another challenging question, but I have faith in you. So now, instead of drawing diagrams, just think about the words. So think about, if it helps, you can draw the diagram out. So in the central and eastern Himalayas, most of the precipitation that we get falls during the summer months, falls during the warm summer months. So will the effect of glaciers disappearing in those particular areas, so the central and eastern, will that be a large effect on downstream populations or small effect? So again, think for a couple of minutes, talk to your neighbors. Okay, any more? Last few seconds. Right, let's see if we've got it or not. From the puzzled faces, I'm not sure I'm hugely optimistic. Think again. Not going to let you get away with this. It does take some thought. So think about what's happening. We're getting our precipitation in our warm summer months. Okay, so if you haven't had a chance to vote, perhaps if you could put your vote in, and we can see if we did any better this time around again. Right, let's take a look. A little bit better. And again, at least it shifted to the right answer. It's always much more depressing if it shifts to the wrong answer. So it would have a small effect. Someone who voted that, tell me why would it have a small effect if we lost glaciers there? Sorry? I heard you.
It's during the summer months, so it wouldn't really matter.
Absolutely. So if we're thinking about when glaciers are contributing water to streams, they're doing it in the warm summer months, right? So if we're already getting lots of rainfall and precipitation in the summer months, then whether we have that contribution from glaciers or not is not going to be as important. If instead we had our wet season in the colder periods, then it would make much more of a difference. Yes? No? Maybe? Yes? Okay, good. It's a little bit of a thought experiment. Okay. So we are already seeing this. So this is worth saying that just as I've shown you that we have seen dramatic disappearance of ice and snow in large parts of the world, this is something that we are already seeing. We are seeing changes in the patterns of the stream flow that we're measuring. And in some places, or in a lot of places, we're seeing an increase, okay? And that's a sign that we're seeing increased melting. But the problem is that our glaciers are only so big. So yes, we're going to see an increase in the meltwater for, say, the next 20, 30, 40 years, depending on how big the glacier is and how much it's warming up. But after a certain amount of time, then our glacier has shrunk so much that the amount of water coming off that is actually going to start decreasing. And then when we've melted our glacier completely, we're not going to have any more meltwater coming from that glacier anymore. So what we're going to hit is something called peak water. So when we're seeing the maximum amount of melting, and so we're seeing the maximum amount of meltwater coming off, and then after that our glacier has shrunk so much that we see less and less and less and less water until it disappears. And in some places we think we've already passed that. In some places in South America we're worried that we've already passed that, especially in low latitude, low altitude areas. The further north you are, the higher up you are, the safer you are so far. But it's going to affect all glaciers. And so unsurprisingly, if you model the effect of things like how much ice you have, how big your catchment area is, how much snow or rain you get different effects on the downstream population. But you can see that in all of our models, it depends how sensitive they are, but that peak water tends to happen around the middle of this century, and then we get a decrease towards 2100, and then it levels out. It basically is matching the precipitation that we're getting. Okay? So in general, we're just going to see much more variability. We're going to see more melt, more drought in some places, and so it's going to be more difficult for people to deal with it. So, effects on humans. I won't insult your intelligence again at this point by asking why we need water. We need water to survive. We need it to drink. We need it to grow crops. We are increasingly using it in a lot of these remote areas to generate electricity. Okay? And so if it gets really extreme, then we're talking about mass movement of people again. We cannot live without water. So if agricultural areas don't have the water, then we can't support the populations there. They will move. Where will they move? They will move to urban areas, and that will create its own social issues. Okay? And it's one of those things, again, that unfortunately climate change attacks those countries. Well, not attacks, that's a very violent word, but climate change affects those countries that are some of the poorest and less able to deal and pay for sort of mitigating that hazard. And it's a shame because usually these countries have had the least input to the problem. And so it's a very unfair system. So let's look at a couple of examples. So let's look at Pakistan. Pakistan, those of you who don't know where it is, should know where it is. It's next to India, okay? And so it's the sixth most populous country in the world. So it's actually a very, very big country. And it's really very rapidly growing its population as well. A quarter of its land is used for agriculture, but actually it's a really quite hot, arid environment. And although it gets some summer monsoon rains, those are often concentrated in the mountains, the Himalayas to the north. And so this network of rivers that you can see running down here are really important for supporting the agriculture and the populations here. As you can see from this satellite map, you can see that stripe of green following the rivers through that country, and to either side it really looks very dry. And so that river Indus, the one you can see running down there, it provides 75% of the water needed for agriculture. It provides 34% of the electricity produced in Pakistan. And 50% of the water in that river comes from glaciers up in those Himalayan mountains. Okay? That's a significant chunk of water, especially in a country where its water needs are growing rather than shrinking. And so really, if we're thinking about sort of decades from now, long-term decreases really could threaten the prosperity of this country and threaten the health of the population. And the Indus River and how much is used, because it's a shared river between India and Pakistan at certain points in its path, that's already causing conflict in an area which is politically not terribly stable. Okay? So that's a potential point of concern. The other one is Bolivia. So Bolivia is one of the countries in the Andes. If you don't know where it is, you have a map. You should mark it on your map. Okay? And you can see that it has sort of lowland areas, but a lot of it is really, really very high up. In particular, we have the city of La Paz, which is its capital city. And they're basically two cities next to each other. And one of them is much richer than the other. So it has 2 million inhabitants right now, and it's growing often because of the changes in water supply for the agricultural communities around it. Okay? And so, unfortunately, I don't think I have time, but there's 2 videos there, sort of 5-minute videos or so, that show you some of the concerns there. So in the wealthier of the cities, it looks very much like Irvine. There's beautiful green landscaping everywhere, and people don't seem to be aware of the problem. In the twin city, the poorer city next door, then a lot of the inhabitants there have never had running water supply to their house. And as the water supply dries up in a number of places, they have to walk a really long way to find that water supply. And as water supplies dwindle, then again, you can't be as picky about the quality of the water as well. And so these issues sort of pile on. And so a lot of the water that comes to feed La Paz, probably 20% of the water that comes into that, especially in the summer months, don't pack up yet, shush. Okay, it comes from glaciers, and they are disappearing. They've already lost one. They will potentially lose more. And so what can we do? Well, we can build reservoirs. But how long does it take to build reservoirs? It takes probably a decade to get the money to actually build it before it becomes usable. In all that time, that water is rushing away and it's lost. And also the country just doesn't have that money to spend, okay? So I did have one last iClicker question, which is, Bolivia is feeling some of the worst effects of climate change, and really they are not the culprits. They are not the ones that have pumped out a lot of CO2. So what they've asked for is money from the community, the broader world community. So do you think that the US and European countries should provide funds for these countries to help adapt to climate change? And obviously there's no right or wrong answer here. It's just a moral judgment, but I'm interested. Okay, so let's take a look at what people think. Shh. I'm not going to talk over you. Okay. It's an interesting, I'm encouraged. Okay, so what can be done? Those things can be done, but you're not going to sit and listen to me. So we'll talk more on Monday.